The year is 1967. The location is a humid, suffocating concrete bunker buried deep beneath the jungle canopy of North Vietnam. The air inside is thick with the smell of ozone, cheap tobacco and nervous sweat. This is the nerve center of a Soviet-supplied S-75 Dvina surface-to-air missile battery. For the Russian military advisors standing behind the North Vietnamese operators, the war has settled into a grim, predictable rhythm. They know the American tactics. They know the heavy, lumbering drone of the B-52 bombers. They know the agile, desperate weaving of the F-4 Phantoms. They understand the geometry of the sky. They believe that while the Americans have volume, the Soviet Union has the superior missile technology. They believe the airspace is a contest they can win. But on this specific morning, the laws of physics seem to break. The radar operator, a young man whose eyes are rimmed with red from sleepless nights, suddenly leans forward. His hand trembles slightly as he adjusts the gain on the P-12 early warning radar. The sweeping line of the scope, the sweep, illuminates a blip. Usually, a blip moves incrementally. It appears, the sweep rotates, and 4 seconds later, the blip has moved a few millimeters across the glass screen. This is how an airplane moves. But this blip does not move like an airplane. In the 4 seconds it takes for the radar antenna to complete one rotation, the contact has jumped a massive distance across the grid. The operator blinks, assuming a glitch. He wipes the glass with his sleeve. He waits for the next sweep. The blip jumps again. It is traversing the entire engagement envelope of the missile battery in seconds, not minutes. The operator calls out the data, his voice rising in panic. He reads out a speed calculation that makes no sense. He is reporting a target moving at nearly 1,000 meters per second. The Soviet advisor steps in, shoving the operator aside. He stares at the green glow. He checks the equipment. He looks for signs of electronic jamming, the snow that usually clutters the screen when Americans are using electronic countermeasures. There is no jamming. The signal is crisp. It is solid. It is real. "It is a ghost," the advisor mutters in Russian. "Nothing flies that fast." The logic of 1967 dictates that he is right. A bullet fired from an AK-47 rifle travels at roughly 715 meters per second. The object on the screen is moving significantly faster than a rifle bullet. It is a physical impossibility for a manned aircraft. The order is given to track it, but the fire control radar, the fan song, struggles to even lock on. The mechanical gears of the radar dish outside are screaming, trying to traverse fast enough to keep the object in the beam. It is like trying to track an artillery shell with a pair of binoculars. Finally, they get a partial lock. The firing key is turned. 2 V-750 missiles roar off the rails outside, turning the jungle clearing into a storm of dust and fire. These missiles are the pride of the Soviet defense industry. They are designed to kill anything in the sky. They accelerate to Mach 3. The crew watches the scope, waiting for the inevitable blossoming cloud of the kill. Instead, they watch something that defies their understanding of warfare. The target does not evade, it does not bank, it does not deploy flares. It simply flies in a straight line, and it pulls away from the missiles. The missiles, pushing their rocket motors to the limit, eventually run out of fuel and self-destruct in useless puffs of smoke miles behind the target. The target continues, unbothered, crossing the entire country of North Vietnam in less time than it takes to smoke a cigarette. Then, it vanishes off the edge of the scope, heading back out to sea. Silence descends on the bunker. The Soviet advisor looks at his North Vietnamese counterparts. There is no explanation he can offer. He cannot tell them what they just saw, because if he admits that an American aircraft can outrun their fastest missiles, he is admitting that their entire defensive strategy is obsolete. He picks up the phone to report the contact to headquarters in Hanoi. But he hesitates. How do you report a ghost? How do you tell Moscow that the enemy has built a machine that treats physics as a suggestion? This was not an isolated incident. Across the globe, from the borders of the Baltic Sea to the edges of the Kamchatka Peninsula, Soviet radar operators were beginning to see the same phantom. A signal that appeared out of nowhere, violated their airspace with total impunity, and vanished before interceptors could even warm up their engines. It was the beginning of a mystery that would haunt the Soviet High Command for 2 decades. It was a technological shock that would force them to spend billions of rubles chasing a shadow they could never catch. If you are fascinated by the hidden stories of military history and the technology that defined the superpower standoff, make sure you are subscribed to Cold War Impact. We investigate the machinery and the strategy behind the conflicts that shaped our world. The immediate aftermath of that first encounter in the Vietnamese jungle was not just confusion, it was a deep, creeping dread. To understand why this ghost was so terrifying, you must understand the Soviet mindset of the 1960s and 70s. The Soviet Union was a fortress. Its military doctrine was obsessed with the sanctity of its borders. They had built the most extensive, dense, and expensive air defense network in human history. Thousands of radar stations, tens of thousands of surface-to-air missiles, and thousands of interceptor aircraft, like the MiG-21 aircraft and the newer MiG-23 aircraft, were arranged in a massive ring of steel around the motherland. This network was designed with one specific purpose: to stop American nuclear bombers. The logic was simple. If the Americans tried to attack, the Soviet radar would see them, the missiles would shoot them down, and the motherland would survive. This belief was the foundation of their national security. But this new contact, this fast-moving ghost, shattered that foundation. If this object was a bomber, it meant the Americans could fly a nuclear weapon into the heart of Moscow, drop it on the Kremlin, and be halfway back to base before the Soviet defenses could even react. It meant that the billions of rubles spent on the S-75 and S-125 missile systems were wasted. It meant the fortress was not secure. It meant the roof had been blown off the house. The reports began to trickle up the chain of command. At first, they were dismissed. Generals in Moscow, sitting in comfortable offices far from the front lines, accused the radar operators of drinking on the job. They accused them of equipment maintenance failures. They claimed the operators were seeing electronic phantoms, or echoes from weather patterns. An aircraft cannot fly at 3,500 kilometers per hour. A senior general of the PVO, the Air Defense Forces, reportedly shouted at a briefing, "The heat would melt the aluminum airframe, the engines would explode, it is a fantasy." But the reports kept coming. From the Kamchatka Peninsula in the Far East, operators reported a contact skirting the coastline, triggering every alarm in the sector and then disappearing into the stratosphere. From the Barents Sea in the north, operators watching the approach to the naval bastions of Murmansk reported a similar signature. A blip that appeared at 20,000 meters altitude, far higher than any known jet, and cruised at speeds that made their interceptors look like they were standing still. The Soviet intelligence apparatus, the GRU and the KGB, began to panic. They were not dealing with a rumor anymore. They were dealing with a consistent, repeatable phenomenon. The stakes were raised even higher when they realized what the ghost was likely doing. It wasn't bombing them. Not yet. It was watching them. Every time the ghost appeared, it flew over sensitive areas. It flew over new missile sites. It flew over submarine pens. It flew over nuclear testing grounds. The Soviets realized with horror that the Americans were photographing them. The ghost was a spy. And it was a spy that walked right through the front door, snapped pictures of their most secret projects, and walked out again, laughing at the guards on the way. This was a humiliation. For a superpower that prided itself on strength, being watched by an untouchable enemy was intolerable. It wasn't just a tactical problem, it was a psychological blow. It signaled a gap in technology that the Soviets had not anticipated. By the end of the 1960s, the ghost had become the single highest priority target for the Soviet Air Defense Forces. The order went out from the Kremlin to every radar station, every missile battery, and every airbase. Identify the target and destroy it at all costs. But as the 1970s dawned, the Soviets would find that identifying the ghost was difficult, but destroying it would prove to be impossible. They were about to embark on a frantic, paranoid investigation that would lead them to question the capabilities of their own industry and drive them to design extreme, dangerous machines in a desperate attempt to catch up. The mystery had arrived. The hunt was on. But the hunters had no idea that they were chasing a machine that was already 10 years ahead of anything they could even imagine. By 1970, the ghost had ceased to be an isolated rumor. It had become a bureaucratic nightmare for the Kremlin. The initial dismissal of the radar operators had been replaced by a cold, hard panic within the highest levels of the Soviet military-industrial complex. The investigation began not in the skies, but in windowless rooms in Moscow. The PVO Strany, the National Air Defense Troops, formed special committees to analyze the radar tapes coming in from Vietnam, from the Kola Peninsula, and from the borders of the Middle East. They played the recordings back, over and over again. They watched the blip traverse the screen. They measured the distance with calipers. They calculated the velocity with slide rules. The math always yielded the same impossible result. The target was cruising at speeds exceeding 3,200 kilometers per hour. Even more terrifying was the altitude. The triangulation data placed the object at nearly 26,000 meters, over 85,000 feet. To put this in perspective for the Soviet engineers, the air at that altitude is so thin it is technically a vacuum. It is the edge of space. Conventional jet engines cannot breathe there. Conventional wings cannot generate lift there. The blood of a pilot without a pressurized suit would boil instantly at that height. The lead engineers at the Mikoyan and Sukhoi design bureaus were summoned to explain what they were seeing. These were the men who built the MiG-15 aircraft and the MiG-21 aircraft. They knew aerodynamics better than anyone in the Soviet Union. Their initial conclusion was denial. "It is a measurement error," one report famously suggested. "The Americans are using electronic warfare to project a false target ahead of the actual aircraft." This theory, the electronic ghost theory, became the comfortable lie for the generals. It was easier to believe the Americans were tricking the radar than to believe they had built an engine that could sustain Mach 3. But the pilots knew better. As the incursions continued, the Soviet Air Force began scrambling interceptors to visually identify the intruder. This was a suicide mission, but the pilots of the MiG-21 aircraft were proud and fearless. One such account comes from a pilot stationed near the Baltic coast in 1972. The alert siren screamed. The ground controllers vectored him toward a contact moving south along the border. The pilot pushed his MiG-21 aircraft to its absolute limit. He engaged the afterburner, dumping fuel into the exhaust to gain every ounce of thrust. He climbed. 10,000 meters. 15,000 meters. The engine temperature gauge redlined. The airframe shook as he approached Mach 2. He was pushing the aircraft to a height where it was barely controllable, wallowing in the thin air like a boat in a storm. The ground controller screamed in his ear, "Target is directly above you! Look up! Look up!" The pilot strained his neck against the G-force. He looked through the canopy glass into the dark purple zenith of the stratosphere, and he saw it. It was not a glitch. It was not a radar trick. It was a physical object. A dark, triangular silhouette, moving with a serene, terrifying smoothness. It was leaving a contrail that looked like a white scar cut across the heavens. "I see it," the pilot reported, his breath ragged in his oxygen mask. "It is massive. It is black. It is leaving me behind." As he watched, the object accelerated. It did not just pull away, it disappeared. It was moving so fast that the pilot felt as if he were hovering stationary in the sky. He tried to pursue, but his engine flamed out in the thin air. He fell back toward the earth, his aircraft tumbling, while the ghost continued on its path, indifferent to his existence. Reports like this shattered the electronic ghost theory. The Soviets now accepted a new, darker reality. The Americans had built a super bomber. This led to the phase of wrong conclusions. The Soviet intelligence analysts began to dig through everything they knew about Western aviation. They became obsessed with the North American XB-70 Valkyrie. The Valkyrie was a massive, six-engine American prototype bomber designed in the 1960s. It was white, it was huge, and it was fast. The Soviets knew about it. They had feared it for years. Though the Americans claimed the XB-70 program had been cancelled, the suspicious minds in the KGB refused to believe it. They faked the cancellation, the intelligence briefings whispered. "They have built a secret fleet of Valkyries. They are testing them on our borders." This belief drove the Soviet response into a frenzy. If the Americans had a fleet of Mark III nuclear bombers, the Soviet Union was defenseless. The ghost wasn't just a spy. In their minds, it was the precursor to a nuclear first strike. They began to look for patterns. They noticed the ghost often appeared during times of international tension. When the Israelis and Arab states were at war, the ghost was there. When the US Navy conducted exercises in the Pacific, the ghost was there. It was mocking them. The psychological toll on the Soviet radar crews was immense. There is a concept in military psychology called learned helplessness. When you are repeatedly subjected to a threat you cannot stop, you stop trying. Commanders reported that radar operators would see the high-speed blip and simply not report it. Why bother? Why wake up the general? Why launch expensive missiles that would only explode miles behind the target? They began to call the object the bastard, or simply him. "He is back," they would say, watching the screen, and they would just watch. But the Kremlin could not afford to just watch. The pressure on the scientific community became unbearable. The order came down from the General Secretary himself. Build something that can catch it. This demand sparked the most expensive and desperate industrial project in Soviet aviation history. The engineers at the Mikoyan Design Bureau were told to throw out the rulebook. They were told to build an interceptor that was pure engine. They were told to disregard fuel economy, disregard maneuverability, and disregard safety if necessary. "We need speed," the generals demanded. "We need altitude. We need a missile carrier that can climb to the edge of space and kill this thing." This desperation would eventually lead to the creation of the MiG-25 aircraft, known to NATO as the Foxbat. But in the early 1970s, the Foxbat was still just a blueprint and a dream. In the meantime, the Ghost kept coming. And then the Soviets caught a break. Or so they thought. Intelligence agents operating in the United States began to pick up whispers of a project with a strange code name. It wasn't the Valkyrie. It wasn't a bomber. It was something else entirely. They heard rumors of a skunk works. They heard rumors of a plane built out of titanium, a metal so difficult to work with that the Americans shouldn't have been able to manufacture it in such quantities. They heard rumors that the United States government was setting up shell companies to buy titanium from the only country that had enough of it, the Soviet Union itself. The realization hit the KGB analysts like a physical blow. The pieces of the puzzle started to click together, forming a picture that was even stranger than their theories. The Americans weren't using magic. They were using Soviet metal. The investigation had found the materials. Now, the Soviets needed to understand the machine. They still didn't know what it looked like up close. They didn't know how it navigated. They didn't know its weaknesses. But thousands of miles away, in the high desert of Nevada, the Americans were about to push the Ghost even harder. They were preparing to operationalize the aircraft fully, sending it not just to the borders, but deep into the most hostile airspaces on Earth. While the Soviets were building a hammer to crush a fly, the Americans had built a needle that could slip between the atoms of the Iron Curtain. While the generals in Moscow were chasing phantoms and the radar operators in Vietnam were staring at their screens in disbelief, the answer to their mystery was sitting on a runway under the baking sun of the Nevada desert. It was not a ghost. It was not an alien spacecraft. It was a machine built by human hands, but it was a machine born from a philosophy that the Soviets could not comprehend. To find the source of the Ghost, we must travel to Burbank, California, specifically to a windowless, unair-conditioned hangar known as the Skunk Works. The man in charge was Clarence Kelly Johnson. If the Soviet engineers were the masters of brute force building bigger rockets and heavier steel tanks, Kelly Johnson was the master of the impossible. He was an aerodynamic genius who ran his team with an iron fist and a simple rule: be quick, be quiet, and be on time. The project that would terrify the Soviet Union began not as an act of aggression, but as a reaction to failure. In 1960, the Soviets had successfully shot down a U-2 spy plane piloted by Francis Gary Powers. The U-2 was high-flying, but it was slow. It was a glider. The Soviets proved that with enough missiles and enough persistence, they could hit a slow target, no matter how high it was. The CIA came to Johnson with a problem. They needed to see into the Soviet Union, but they could not afford to lose another pilot. They asked for a plane that was invulnerable. Johnson looked at the physics and realized there was only one way to achieve invulnerability in the 1960s. You didn't hide, you outran. He proposed an aircraft that would fly at Mach 3.2 over 3,500 kilometers per hour. He proposed an aircraft that would fly at 85,000 feet. He proposed a machine that would move faster than a rifle bullet, continuously, for hours at a time. The engineering challenges were so immense that they sounded like fiction. The first problem was heat. Friction is the enemy of speed. When an object moves through the atmosphere at Mach 3, the air in front of it is compressed so violently that it creates a shockwave of superheated plasma. The nose of the aircraft would reach temperatures of over 300 degrees Celsius. The exhaust section would reach over 500 degrees. If you built this plane out of aluminum, the standard material for aircraft like the Boeing 747 or the MiG-21 aircraft, the airframe would simply lose its structural integrity. It would soften and warp like a plastic spoon in a microwave. The only metal that could withstand that heat while remaining light enough to fly was titanium. And this brings us to one of the greatest ironies of the Cold War, a secret that the KGB analysts hunting the Ghost would have killed to know. In the 1960s, the United States did not have a significant supply of high-grade titanium ore. The world's largest supplier, with the purest reserves, was the Soviet Union. The CIA realized that to build the plane designed to defeat the Soviet Union, they needed to buy the metal from the Soviet Union. A covert operation was launched. The CIA set up a network of dummy corporations and shell companies across third-world countries. These fake businesses purported to be manufacturing everything from golf clubs to pizza ovens. They placed orders for thousands of tons of Soviet titanium sponge. The Soviet trade officials, eager for foreign currency, happily sold the ore. They signed the invoices. They loaded the ships. They had no idea that the metal they were exporting would be forged into the skin of the Blackbird, the very ghost that would soon be humiliating their air defenses. The irony was absolute. The USSR provided the raw materials for their own strategic nightmare. With the material secured, Johnson's team began to build the SR-71. The shape was unlike anything ever seen. It was long, slender and flattened, with chines running along the sides to provide lift and stability at supersonic speeds. It was painted a dark midnight blue, almost black, to dissipate heat and blend in with the dark sky at the edge of space. This earned it the nickname the Blackbird. But the heat created another problem. When metal gets hot, it expands. At Mach 3, the SR-71 grew. The fuselage would stretch by several inches in length. If the engineers bolted the panels together tightly on the ground, the plane would buckle and tear itself apart in the air when it heated up. So, Kelly Johnson did something counterintuitive. He designed the plane to be loose. He designed the panels with gaps. On the ground, at ambient temperatures, the SR-71 rattled, and it leaked. The fuel tanks were the skin of the wings. Because of the gaps needed for thermal expansion, the specialized JP-7 fuel would weep through the joints. When an SR-71 sat on the runway, it sat in a puddle of its own fuel. It was a messy, dripping beast. But once it took off and accelerated, the friction heated the titanium. The metal expanded, the gaps closed, the seals tightened, the aircraft became solid. It was a machine that only worked properly when it was burning up. The engines that powered this beast were equally revolutionary. The Pratt & Whitney J58 engines were hybrids. At low speeds, they worked like normal turbojets. But as the plane accelerated past Mach 2, a massive inlet spike in the front of the engine would retract, changing the airflow geometry. The engine would essentially convert into a ramjet, using the sheer force of the incoming air to compress and ignite the fuel. It was the only aircraft in history where the faster you went, the more fuel efficient the engines became. It was designed to live at Mach 3. For the pilots, flying the SR-71 was closer to being an astronaut than an aviator. They wore full pressure suits, the same gold-visored suits used by the Gemini and Apollo crews. They breathed pure oxygen. They were strapped into a cockpit that was an analog marvel of dials and switches, staring out of small quartz windows that were an inch thick to prevent them from melting. The first operational flights began in the mid-1960s. The pilots nicknamed the plane Habu, after a venomous pit viper found in Okinawa because of its cobra-like shape and its lethal reputation. When the SR-71 entered hostile airspace, the pilot and the reconnaissance systems officer, RSO, in the back seat were not looking for a fight. They were looking for data. They carried cameras and sensors of unprecedented power. The optical cameras could photograph a license plate on a car from 80,000 feet while moving at 3 times the speed of sound. The side-looking airborne radar could map the terrain of a country sideways without ever crossing the border directly. But the true weapon of the SR-71 was its operational doctrine. When a Soviet radar operator detected the Blackbird, the pilot in the cockpit would see a warning light. The RWR radar warning receiver would light up. In a normal plane, a pilot screams for help or dives for the ground. In the SR-71, the pilot simply moved the throttle forward. The standard operating procedure for avoiding a missile was accelerate. The pilot would push the nose up and the throttles to the stops. The Blackbird would climb higher and fly faster. The Soviet missiles, burning their fuel to catch up against gravity and drag, would simply run out of energy. They would stall and fall back to Earth, miles below the Blackbird's tail. This was the machine that was tormenting the Soviet Union. It was a triumph of American daring and engineering. It was a plane built from stolen Soviet metal, flying on fuel that needed a chemical explosion just to ignite, piloted by men in spacesuits, surfing on the very edge of the atmosphere. While the Soviets were holding committee meetings and interrogating their radar crews, the Americans were flying above them, looking down, and taking pictures of the confusion. But the game of cat and mouse was about to reach a breaking point. The Soviets were not stupid, they were learning, and they were preparing a trap. The mystery was solved for the Americans. But the Soviets were about to have their own moment of clarity, a moment that would shake them to their core. By the mid-1970s, the mystery of the ghost had technically been solved, but the terror had only deepened. The Soviet intelligence agencies had finally put a name to the silhouette. They called it the SR-71. In the briefing rooms of the Kremlin, it was no longer a phantom. It was a concrete reality, a tangible collection of titanium and glass that was actively humiliating the Red Army. The initial confusion of the radar operators had been replaced by a cold, calculated fury. The Soviet Union did not accept second place. If the Americans had a plane that could fly at Mach 3, the Soviet Union would build a plane that could kill it. This determination birthed the reveal of the Soviet counter-strategy. It was a moment where the entire industrial might of the USSR was focused on a single point: interception. The result was the MiG-25 aircraft. To the west, when the MiG-25 first appeared in grainy spy photos, it looked terrifying. It had huge wings, massive air intakes, and twin tail fins. It looked faster than anything NATO possessed. Western analysts panicked, fearing the Soviets had built a superfighter that could outmaneuver and outrun their best jets. But the Soviet pilots and engineers knew the truth. The MiG-25 was not a fighter. It was a manned missile. It was a brute force answer to a high-tech problem. While the American SR-71 was built of elegant, exotic titanium to withstand the heat of sustained high-speed flight, the Soviet Union lacked the advanced welding techniques to work with titanium on that scale. So, they built the MiG-25 out of stainless steel. Steel is heavy. To get this heavy steel beast off the ground and push it to Mach 3, they had to strap it to two Tumansky R-15 turbojet engines, massive power plants that were originally designed for cruise missiles and drones. These engines were not designed for finesse, they were designed for violence. The radar on the nose of the MiG-25, the RP-25 Smerch, was so powerful that pilots were forbidden from turning it on while on the ground, because the radiation output would kill rabbits near the runway and boil the alcohol in the de-icing systems of nearby trucks. It was a burn-through radar, designed to punch through American jamming by sheer kilowatt output. The Soviet High Command believed they finally had their solution. They deployed the MiG-25 regiments to the borders. They waited. The confrontation that would reveal the true depth of the disparity happened not in a single dramatic battle, but in a series of high-stakes duels over the Barents Sea and the Baltic Sea in the late 1970s. Imagine the scene inside the cockpit of a MiG-25 aircraft stationed at a bleak airfield near Murmansk. The alarm sounds. The ground controller screams that a blackbird is on the scope. The pilot scrambles. He ignites the massive Tumansky engines, feeling the raw vibration rattle his teeth. He takes off and immediately begins a steep, aggressive climb. The intercept profile was mathematically brutal. The SR-71 was cruising at 24,000 meters. The MiG-25 could technically reach that altitude, but only for a moment. The Soviet pilot had to fly a snap-up trajectory. He had to sprint toward the target, turn on his afterburners, and hurl his heavy steel aircraft upward like a stone from a slingshot. He had a window of perhaps 2 or 3 seconds to get a radar lock and fire his massive R-40 missiles. The shock moment for the Soviet military came during these intercepts. The pilot would push his aircraft to the limit. The Mach meter would climb, Mach 2.5, Mach 2.8. The red lights on the dashboard would scream. The engine temperature gauges would bury themselves in the danger zone. At Mach 2.8, the engines of the MiG-25 would begin to overheat uncontrollably. The force of the air entering the intakes was so great, it threatened to tear the compressor blades apart. The pilot would look at his radar screen. He would see the SR-71. And then, he would see the SR-71 accelerate. This was the moment of absolute realization. The American pilot, seeing the threat, would simply ease the throttle forward. The Blackbird, already flying at Mach 3, would effortlessly slide up to Mach 3.2 or 3.3. The MiG-25 pilot, sitting in his shaking, overheating steel cockpit, would watch the target pull away. He was pushing his machine to the point of destruction just to catch a glimpse of the enemy, while the enemy was cruising comfortably, likely with the autopilot on. If the MiG-25 pilot tried to push past Mach 3 to catch up, the physics of the Soviet engines would fail. The turbines would melt. The engines would effectively turn into scrap metal. There are reports of MiG-25 aircraft landing after these intercept attempts with their engines completely ruined, fused into solid blocks of metal requiring total replacement. The aircraft had to be towed off the runway because they could not taxi. The reveal was devastating. The Soviets realized that while they had matched the speed number, they had failed to match the capability. The SR-71 was a marathon runner. It could run at top speed for hours. The MiG-25 was a sprinter that collapsed after 100 meters. The futility of the response became clear in the debriefing rooms. The generals looked at the data. They had the most powerful radar, the biggest missiles, and the fastest interceptor they could build, and they still could not guarantee a kill. They tried everything. They set up ambushes. They tried to predict the SR-71's flight path and position a MiG-25 directly in front of it for a head-on shot. But the closing speed of a head-on intercept between an SR-71 and a MiG-25 is over Mach 6. That is nearly 2,000 meters per second. The human eye cannot process it. The fire control computer barely has time to register the target before it is already behind you. By the time the MiG-25 pilot's brain registered lock, the SR-71 was gone. The final insult came from the technology gap in the missiles themselves. The Soviet missiles were designed to maneuver, but at 80,000 feet, the air is so thin that aerodynamic fins have almost no grip. To turn the missile, you need massive control surfaces. The SR-71 could simply make a gentle turn, and the Soviet missiles, screaming through the thin air, would drift wide, unable to correct their course in time. The Soviets were left with a grim conclusion. They had built a defense network that cost billions of rubles. They had trained elite pilots. They had pushed their industrial base to the breaking point. And yet, the ghost continued to fly. It continued to take pictures. It continued to remind them every single week that the sky did not belong to the Soviet Union. It belonged to the country that could solve the thermal problems of titanium. The realization wasn't just about a plane, it was a systemic shock. The Soviet leadership began to understand that the West wasn't just ahead in production, they were ahead in the fundamental science of materials and computers. The SR-71 wasn't just a spy plane, it was a flying billboard for the failure of the Soviet command economy to innovate. They had chased the ghost for 20 years. They had caught nothing but their own exhaustion, and as the Cold War entered its final decade, the lesson of the SR-71 would become a prophecy for the collapse that was to come. The ledger of the Cold War is often written in blood, proxy wars, and political posturing. But the true story of the conflict between the SR-71 Blackbird and the Soviet Air Defense Forces is written in a single, devastating statistic. It is a number that defines the difference between a superpower that relies on volume and a superpower that relies on unmatched innovation. Over the course of 24 years of active service, from 1966 to 1990, the SR-71 Blackbird flew thousands of operational sorties. It flew over Vietnam. It flew along the borders of the Iron Curtain in Europe. It flew over the heavily defended ports of the Kola Peninsula. It flew over North Korea. It was painted by Soviet radar tens of thousands of times. According to declassified military archives and Air Force historical records, the Soviet Union and its allies fired approximately 4,000 surface-to-air missiles at the SR-71. 4,000 missiles, and the number of Blackbirds lost to enemy fire was 0. Not a single aircraft was shot down. Not a single pilot was lost to combat. The ghost that had terrified the radar operator in the Vietnamese jungle in 1967 remained a ghost until the very day it was retired. This statistic, 4,000 to 0, is perhaps the most lopsided victory in the history of aerial warfare. It represents a total failure of the Soviet philosophy of denial. The impact of this failure on the Soviet Union was profound and systemic. The existence of the SR-71 forced the Kremlin to bleed its economy dry. They spent billions of rubles upgrading their radar networks to track a plane they couldn't hit. They built the MiG-25 aircraft, and later the MiG-31 aircraft, specifically to counter this threat. While the MiG-25 aircraft was a formidable machine, a triumph of brute force engineering that set its own speed records, it was ultimately a reactive weapon. It was a symbol of a nation that was always one step behind, breathless and sweating, trying to catch up to American technology. The irony is that the SR-71 did more damage to the Soviet Union by simply existing than it would have if it had been a bomber. It did not need to drop explosives. It dropped the realization of inferiority. Every time a Soviet general looked at a satellite photo of an SR-71 sitting on a runway in Okinawa or the UK, he was looking at a machine made of Soviet titanium, built with computer-aided design that Soviet engineers did not possess, flying on engines that defied Soviet metallurgy. It forced the Soviet military to keep their air defense systems on constant high-alert status. This fatigue wore down crews and equipment. It forced them to turn on their radars, which allowed American electronic warfare planes to map their frequencies and locations. By trying to hunt the Blackbird, the Soviets revealed the blueprint of their own defense network to the enemy. The Blackbird was the ultimate strategic bait. In the end, the SR-71 was not defeated by the Soviets. It was defeated by the accountant. By the 1990s, the Cold War was ending. Spy satellites could do much of the reconnaissance work without risking a pilot. The cost of maintaining the fleet of titanium birds became hard to justify in a world without a Soviet Union. The Blackbird was retired. The hangars were closed. The dripping fuel on the runway dried up. But the legacy of that ghost remains one of the most powerful narratives of American dominance in the 20th century. Today you can visit these machines in museums. You can stand under the black-chined fuselage at the Smithsonian or the Air Force Museum. Even sitting still, covered in dust, the SR-71 looks like it is moving. It looks like it fell out of the future. And if you look closely at the titanium skin, you might remember the story of the radar operators in the dark bunkers of the Cold War. You might imagine the panic in their voices as the blip jumped across their screens. They witnessed something that shouldn't have been possible. They witnessed a machine that turned the lethal geometry of the Cold War into a race that only one side could win. The Soviets fired 4,000 missiles at the sky, hoping to bring down the American Eagle. But the Eagle was already gone, soaring in the silence of the stratosphere, untouchable, leaving nothing behind but a sonic boom and a mystery that would haunt the enemy for a generation. The ghost won. This brings our investigation into the SR-71 Blackbird to a close. The story of the Cold War is filled with these technological duels, where engineering was just as important as infantry. If you enjoyed this deep dive into the ghost, please subscribe to Cold War Impact. We are currently working on a documentary about the Soviet Ekranoplan, the Caspian sea monster that baffled CIA analysts for a decade. You won't want to miss it.